So when you hear Nvidia, what does it come to your mind? So I guess you're aware of Nvidia. Can I just see a show of hands? Trillion dollars. Okay, one good thing. And but would you think about Nvidia beyond chips? Like, what does Nvidia do beyond chips? Anyone can take a guess what we do apart from just building chips and printing money? Any guesses? Exactly. Exactly. So today we want to show you the latest and the greatest things that we are doing, and we want to share that with you, and just we want to make sure that when you leave the room, you take this idea with you that we are just more than just chip builders. What we actually do is we are a platform company, and we want to enable every company in the world to adopt AI in whatever field. And today, since we are in a M&E based event, we want to show what we have to offer in the M&E space. And trust me, there's a lot of things, and 1 hour of time is literally too less to speak on all. I won't be wasting your time on talking about the technicalities, but rather showing you real things that after the session, if you have a spare GPU lying around in one of your systems, or you have a server farm, you can just access. I also have given some links. You can note down that link, take a picture or whatever, and you can just get started, and you can make the things that I'll be showing you with very ease. You don't need to be a creator, because most of the things that I'll be showing is something that we made, and I'm an engineer by profession. I'm not a creative person. So can we please move to the first slide, please? Can we move to the first slide, please? Okay, so what we are showing over here, the first phase, it's all created using generative AI. So we did release a model called Sana, and it's one of the state-of-the-art model. If you want to generate very realistic face, you should take a look at these models. These models are all open source, ready for you to use and consume. And what we are showing, that not only we can just generate faces, if you have an audio, you can create a 2D digital human with ease. So we have something called the audio to face. There's a 2D version and a 3D version. We are going to show you the 2D version today. So if you just can you just play on the click?
એક નવા પ્રકારની વાર્તા કહેવાની સુવિધામાં આપનું સ્વાગત છે, જ્યાં કલ્પના નવીનતાને જોડે છે. તમે જે જોવા જઈ રહ્યા છો તે સંપૂર્ણપણે કૃત્રિમ બુદ્ધિમત્તાની મદદથી બનાવવામાં આવ્યું છે. દ્રશ્યો અને અવાજથી લઈને વાર્તા સુધી દરેક તત્વ એ દ્વારા ઉત્પન્ન થયું છે. તે ફક્ત ભવિષ્યની ઝલક નથી, તે આજે ભવિષ્ય કેવી રીતે બનાવવામાં આવી રહ્યું છે તેની એક ઝલક છે.
So now you don't need to be a creator to animate stuff. So what we are enabling, we are having many software pipelines. So here we are showing you an amalgamation of multiple pipelines. One is the image generation pipeline, which enables you to generate photorealistic faces. Then there's a studio to voice, and then there's a Indic TTS. So the Indic TTS, what it does, you type in a text and you can generate voices. And since we live in a very diverse country, so the models that are out there and the ones that we are displaying today, it takes care of all the 23 languages that are recognized in India. So the accent and everything, then it can also like switch between languages, what we call code switching in technical terms. So if you, let's say, are typing in Hindi, and then a word comes in English, and then again a word comes in Malayalam, most of the models, they won't be able to synthesize the voices. But what we are showing you today, that capability is inherent in our models. And then there's studio to face. So let's say I'm speaking in the mic right now. So if you just integrate this bit of the pipeline, what you get is studio quality voice. Bereft of any distortion, it amplifies your voice and makes your voice sound like it has been recorded in the studio. So you have the image gen part, you have the audio to face, and you have the rest of the pipeline, which you can directly plug in to generate animations like this. What we are going to show next is a video that has been generated from scratch. right from the BGM. For BGM, we released a model called Fugato. Not this one. Can you go back one side, please? Yeah, this one. So here the BGM has been generated using AI. So it's a state-of-the-art model. Again, it's called Fugato. The voices, you can hear the different dialects or the languages that we speak in India. Also, it has been synthetically created, and the video itself is synthetically created. So can someone just hit the play button?
નમસ્તે इस સંમેલન में आपका स्वागत है વાર્તા કહેવાની એક નવી રીતમાં આપનું સ્વાગત છે જ્યાં કલ્પના નવીનતાને સ્પર્શે છે તમે જે જોવા જઈ રહ્યા છો તે સંપૂર્ણપણે AI ની મદદથી બનાવવામાં આવ્યું છે દ્રશ્યો અને ધ્વનિથી લઈને વાર્તા સુધી દરેક તત્વ A દ્વારા ઉત્પન્ન થયું છે આ ફક્ત ભવિષ્યની ઝલક નથી એટી એકટી A તৈরি ভিডিও এটি সংস্কৃতি ভাষা ধর্ম জাতিগততা ভূগোল এবং ঐতিহ্যের অসংখ্য মাত্রা জুড়ে বিস্তৃত যা পরিচয় এবং অভিজ্ঞতার একটি সমৃদ্ধ ইন দ্য কার্নলি ইন্ডিয়াविन कलाचार पन्मुगतन्मये काट्टगिरद आमच्या बूथला भेट दिल्याबद्दल धन्यवाद.
So this is something that we have as a part of the Bharat Pavilion as well. So if you're here and you're visiting the exhibition area, feel free to come to the Bharat Pavilion, because what we are demonstrating there, we show this exact video, and we have an interactive setup where you can go on, type in a prompt, generate the videos that you want, and we'll help you get it on a stick, and you can carry that with you as a memorable. Yeah. So this is offered by Nvidia. So this is open for everyone. So is anyone aware of GTC? Okay, so GTC is our premier conference that is held every year at San Jose. As a part of the conference, Jensen announced these models. So these are part of our company's vision for something known as physical AI. And what our company's vision is, so we believe in the future there will be three sets of computer. One set of computer where you train the large language models, one set of computer where basically you do all the simulations, you take the learning from the simulated model, put it onto your physical system. That can be a humanoid, that can be a AV system. And then you have chips to process the data on board. Like when you have autonomous vehicle that's running, you need something with very high compute capacity, which can deliver you results at very low latency. So this is part of our flywheel for the physical AI system. And if someone can go to the next slide, I can talk about it more. So if you take a look at the link that was being flashed at the top, so it's called Cosmos. So Cosmos is a set of models. So it's not just this video gen model. So it also has a simulation style transfer. Like you created a simulated setup of a bare shell kitchen. Let's say now you want to put your idea, the way you have designed it, and create a digital twin of it. So you can do that. So the physical AI systems also has this text to world, which is the text to video model that I was just showing you. It also has the image to video. So if you have a start frame and you want to, based on that anchor frame, want to generate a sequence of frames or essentially create a movie on top of that, how would you do that? So we have also open sourced the model for that. We call that image to world, which is essentially image to video. And then we have a bunch of model for simulating your robots, the humanoids, which are coming up pretty fast, especially in the West where there's a labor crunch. You'll find them working in warehouses now. It's not something that is in the future. So how do you train such system? Let's say I have 5 types of humanoid robots. Will I individually train them on 1,000, 2,000, 10,000 hours of data? I wouldn't probably do that. I'll just use a simulated setting. So we have a platform called Isaac Sim where we would do this training in the virtual or the simulated space, take the model and just port it onto the actual humanoid robot that you have. So this is a part of our vision for the physical AI revolution. we all are pretty familiar with what generative AI did with our lives, right? I think most of us cannot type in an email without ChatGPT these days. So I think the next thing, at least our company is betting on, is physical AI, and that this is the part we are showing you one of the aspects of the physical AI revolution, where we think we are contributing heavily. Our company is also investing heavily, and we are open sourcing everything for you to take away. Just try it for yourself, and be it a Tinker lab or let's say you are a frontier lab, you can just take our work that we have been doing and build on top of that. So can we move on to the next bit? So this is the part of the journey in the evolution of AI that I was talking about, called physical AI. On to the next slide. Yeah, so this is the 3 computer paradigm that we describe how our future world would look like. So you'll essentially have data centers. The reason why Nvidia became a $1 trillion company was because there was an increase in data center scale GPU consumption. Why these data center scale GPUs are being consumed so heavily? Because when you are training these large language models, you require 100,000, 500,000 of these GPUs crunching data simultaneously to give you these model in realistic time. So let's say you are trying to train a 405B parameter models, a model that came out from Llama. They were running some 100,000 GPUs, and 100,000 GPUs running for 4 to 6 months straight, just crunching numbers parallelly. So that's where you build these large language models. Once you have built them, now you want to take that large language model, you want to embody it into a humanoid. You cannot directly do it. You need, again, a computer system where in a simulated environment, you want to simulate all the interaction. So it's like you trained a new college grad. After you have trained a new college grad, you want to train that grad to do something specific. Let's say work in a warehouse. So that humanoid that you want to train to work in a warehouse, you take that knowledge that you have generated, put it inside the simulated environment in the platform that we call Omniverse, which again has this tight integration with Cosmos. There you can do all your simulation runs and all the reinforcement learning and all the fancy techniques that the scientists, the data scientists, they are coming up with. You can do all your trials in the Omniverse space. This again requires a different set of GPUs. It also requires GPUs, but not the data center class of GPUs that you use to train large language models. Once that is done, now you deploy it in real life. And once you deploy it in real life, again, you require some form of compute because data is coming at you all the time. There's light that's bouncing off me. I'm speaking at the same time. So there's a lot of action that we do simultaneously, which we think that's trivial, but again, cognition is a very difficult problem. It might seem very trivial for us because it comes naturally, but to formalize that problem and put it inside a computer, it's very difficult. So for that, again, we have platforms where we can do all these things, information coming out from different sensors, being fused together in a very low latency setup, because you don't want your AVs to react slow, because a situation can pop up anytime. So this is basically how we envision the world is going to look like. It will be a 3-computer world that we call. One where you train the intelligence, one where you prime it for the real world, and the last where you go and deploy it in low latency real life setup. Can we go to the next slide, please? Which one? Can you please go back once? Mm-hmm. Sometimes you probably, if it's a large language model, let's say it's a vision language model, you do not want to put it inside a humanoid. There might be use cases where I've trained something just where a camera feed is coming. I just want to understand what's happening and do the inference. So it's not like you always have to go to the simulated space. If you want to go to a world where you want to have humanoids interact with you, that's the path you take. But if you have trained intelligence and you want to deploy it That's the pathway. So that's why like you have that arrow. And how do we build this? Can we go to the next slide, please? So yeah, it takes a lot of work to train these models, and you have to collect a lot of information. So you scrape essentially the entire internet. You have 10,000 Nvidia H100, which were up until 6 months back one of the best GPUs in the world. Again, we introduced the next generation GPUs. So this basically is showing you the breakdown of the data set that we collected to train these models. And what we are also telling you that, hey, we not only have trained it for ourselves, but we have made these recipes open source. So there's a stack called Nemo. If you plan to train these video foundation models by yourself, so there's a curation stack, there's a distributed training stack. What you can do is you can leverage all the work that we have done. All the learning has been like it's one script that we have created for you, and you just fine tune some values depending on that use case. And essentially you can start training on 10,000 GPUs, because it's a pretty difficult job synchronizing how these GPUs will work in unison so that you get that final result that you're looking for. So what we are saying is, hey, if you have a problem statement, do reach out to us. We can help you build your video foundation model, large language model, whatever be it. So we have recipes for everything. You have a question, sir? No. Okay.
So this is for what kind of what data you are showing?
So the video generation that I just showed you.
One picture and video.
No, that's the different one where I was showing you there were multiple audio. There was audio in different languages, and then I was showing you a montage of the different places in India, and yeah, it takes a lot of data. Yeah, so to train a frontier model, yeah.
Probably you can answer it right now or at the end of the session. When we are talking about all this training data that you are using, do you even consider the aspect of copyrightability or how you are sourcing the data or any of these things, or it is?
So we work with companies like Shutterstock, and they provide us the data. It's not like we are scraping the internet, taking data from YouTube and taking uncopyrighted or copyrighted data without permission. So we have our partnerships with companies like Shutterstock, Meta. We work in unison. They provide us the data, and that's how we train these video foundation models. Yeah.
We can top it up this layer of training with our own data.
Absolutely. You can come augment with your data. You can choose to build from scratch where you ignore everything that we have collected. You have a use case which is very specific, very focused. You can just ignore whatever we did. You can bring your data, plug it into our systems, and it will work out of the box.
It is possible to filter the existing data sets that you have. For example, we are looking for not for places but for material or things or something like that. So we can segregate the layer and use the existing, or how is it?
There are two answers for this. So again, for material science, we have different models. So maybe I can, after this session, I can connect with you and tell you about some of these material science-based models. We have models for CFD. We have material science models where you can find out new configurations, what we essentially call configuration, which turn out to be materials and metamaterials. You can choose to take them as a base, and on top of that, bring in your flavor, which is proprietary to you. Or you can choose to build everything from scratch.
Furthermore, is there any consistency from here if we make it use your open source or existing models in the market? Maybe like, so is there a character or a element consistency we can have?
Say for example, for the previous ones we have used Sora or in videos or something like that, then now we want to make our own, and we use your open source stack and top it up. So is there any level of consistency? Have you seen any use cases?
I'll just give you an example. So you talked about NVIDIA, right?
Yeah, that's your, I know.
Yeah, so NVIDIA is running on NVIDIA. So not only on our GPUs, we work actively with helping them building the models and optimizing them. So that's how, let's say, we are working with these models you can download. Yes, you can deploy it, have it deployed on your laptop also. There's no requirement of internet till the point if it can fit on your GPU, because these these models have different memory requirements. Some might be heavier, some might be lighter model. So if you have a lighter model, then it can run onto your GPU. Else you might need like a cluster of GPU, 4 or 5 GPUs if you can have it on a server, but it can reside offline. You don't have any requirement for the internet. CFD can be done, yes. Yes, we can show you some examples. If you go to build.nvidia.com, you can find a lot of work that is being done in the field of CFD. Yeah. Can we move on to the next slide, please? Yeah, so we were just showing you, I think covered most of these slides where I was showing you the 3 pathways. One is the video gen path. Why would you require a video gen model? Like apart from creative stuff, what other value does building a video gen model have? Let's say you want to make your autonomous vehicles safer. You cannot capture all possible scenarios just by driving a car with a camera setup which is capturing all the scenes, because the incidents you want to prevent, they're again a one-off incident, probably won't be there in your data set. If it is not there in your data set, since these models are probabilistic models, there's a chance that it might react in a way that's not aligned with how you want it to react. So what we want to also put a messaging across, you can use these video gen models because they generate very photorealistic outputs. You can augment your autonomous vehicle training data also with similar output, because you can type in just a text, generate frame where a driver is driving, the camera captures video, the camera is partially occluded by the right hand. So whatever scenario you want to simulate, you can essentially create the data for that, augment it with your data, and make these models safer. So apart from video gen and creative purpose, that's another use for the video gen foundation models that I was just showing you guys. The top one, Cosmos Predict. Yeah. So these are 3 buckets. So Cosmos Predict and Cosmos Transfer is out now for you guys to explore. So one is essentially if you are creating some 3D configuration and you want to do a style transfer, that's the Cosmos Transfer. So Cosmos Predict, I showed you the video gen part. The Cosmos Transfer is also something, let's say you are an architecture company or an interior design company, that might be pretty useful for you guys. And the reasoning model also, wherein these humanoids are also learning the capability to reason. So that is also something that is in the works and will be coming out in the next few months. And everything will be open source. So
the first one, the data captured through the physically also, and data captured through the sensors can be different.
yes. So we have the recipes where you can fine tune these models based on either the physical data that you are capturing from actual sensors or you are scraping from the internet. Yes, absolutely. So these are all.
I don't know if you give example. Generate all synthetic data for the kind of
Exactly, but you have to augment, right? If you cannot capture the entire distribution, augmenting helps. The more you augment, the better is the outcome the next time you see out of distribution scenario, because you're trying to simulate for that. So this is something what we call simulator learning, where you learn in a simulated environment, take it onto the real world, and you see real applications for that. Yeah.
Can you give me a small brief about the Cosmos transfer? So as you were saying, we can feed it a block out of a 3D model.
Yeah.
It can give us help us with architecture visualization. In that case, can it help us with game development, like simulate game environment?
Just wait for a couple of slides. We'll be there. Yeah. So.
With Cosmos transfer, you see, this all comes like it's not physically as a digital is like a realistic, which I can use for the subsequent operation for trying, etc.
So this is for the digital twin. So you first create a digital twin for everything, because digital twin, every factory in the world, at least like the companies that we are working with, Foxconn is one example, Winston is another example. So everything is built in the digital space first. Everything gets simulated, and then these things are getting developed. So to create more and more realistic digital twin, that is where Cosmos Transfer comes in pretty handy. We'll be happy to take your feedback for that. Yeah, please.
Not into the factory environment. Let's say, let's get into a studio environment, right? So there is a digital twin of individual is all possible. That's really happening. So you mean to say that if we create a digital twin parallelly, and the individual's twin is also created by voice copy over and all that, so generation will be next level. Have you created any examples of creating a digital twin studio?
So the gaming question and your question, they tie up very harmoniously. And
so we can look into it later, you want to?
A couple of slides.
Okay,
and
got that.
If the video plays, I'll be showing you the video. Or offline, I can show you example of digital twin. So we again have a software stack called ACE with which you can build these digital twin. So all the voice-to-voice, RAG, all the technicalities have been abstracted for you so that you can take it out and just run those on your system. So we create something called blueprints. We want you guys to take away these blueprints and customize it for your use cases, whatever you have. So can we go to the next slide, please? This is again, we are showing something what we call the lip sync. Essentially, if you follow our Honorable Prime Minister on Twitter or X, you must have seen Lex Friedman's interview come out with the Prime Minister. And that was dubbed by Sarvam Labs in all the Indian languages. So this is again something, that's the foundation. We are showing you the foundation on which these things were built on. So can you just play the video?
Welcome to GTC. We are thrilled to have you join us for this exciting event. Whether you are here to explore cutting-edge technologies, connect with industry leaders, or discover the future of AI, you are at the right place. Get ready for insightful sessions, inspiring speakers, and groundbreaking innovations. Let's dive in and shape the future together at GTC.
Bienvenue au GTC. Nous sommes ravis de vous accueillir pour cet événement passionnant. Que vous soyez ici pour explorer les technologies de pointe, vous connecter avec les leaders de l'industrie ou découvrir l'avenir de l'intelligence artificielle, vous êtes au bon endroit. Bienvenido a la Conferencia Tecnológica de Gráficos. Estamos encantados de que te unas a nosotros para este emocionante evento. Ya sea que estés aquí para explorar tecnologías de vanguardia, conectar con líderes de la industria o descubrir el futuro de la inteligencia artificial, estás en el lugar correcto.
Willkommen bei GTC. We're freuen uns, dass Sie uns für dieses aufregende Event begleiten, ob Sie hier sind, um Spitzentechnologien zu erkunden, sich MIT-Branchenführern zu verbinden oder die Zukunft von AI zu entdecken. Sie sind am richtigen Ort, machen Sie sich bereit für.
So this is something that we launched at GTC, and within a month's time, Sarvan Lab, one of the frontier lab that we have in India, they adapted this and adapted that for Indian languages, and that's how the Lex Friedman and Honorable Prime Minister's video was dubbed in, I think, 11 languages. So that was put out by the Prime Minister's handle, also by Sarvam Labs. So this is the foundation of that technology. That
Is it fluent when, let's say, we communicate a lot of times in English? It's just English.
There's code switching capabilities. Yes. So this pipeline is not just the lip sync model. You also have the TTS model. The TTS model in itself has the code switching capability. So whatever audio you are generating, the emotions get mapped to the lips and the movement of the face and the torso. So the code switching capability is something that is handled by the TTS. But as a pipeline, yes, you do have that because the TTS handles it.
Can we connect with the backend? I interact with him. I listen to my voice to text.
And then he converts into the back to the chat GPT, get the answer, and then he speaks.
If I can access my laptop right now, I can show you something,
Okay.
or maybe just after the
please,
session.
Please.
So we do have examples of digital humans, where exactly you have like a audio to face 3D model with the ACE character that can be used in game development. That's again a side note. But what we have created as part of this digital human blueprint is you can have a realistic, photorealistic representation of a human that's talking to you. And in the backend, you can have all the sorts of knowledge bases, chat GPTs connected with it. And you can like have a fluid conversation with such systems.
Nvidia provides all stack at one place. Otherwise, we use these apps, use these high reference data.
Yes, so that's why we have created these blueprints, so that you just deploy this blueprint, we take care of the nitty-gritties. Yeah.
The question was that how far are we from the real-time?
Real-time processing, right now the latency is somewhere close to 1.2 to 1.3 seconds. For absolute real-time processing, it needs to come down to 300 milliseconds or lesser, because beyond 300 milliseconds, we won't be able to perceive it. So latency is again a function of many things. If you have powerful GPUs, if you have more and more and more compute, that makes it easier. And it's not the compute, it's also the transfer bandwidth. So if you have faster memory, so that's what all the tech companies in the world are working towards, getting faster memories, getting more compute per unit space. So realistically, it should be maybe within a year's time, you'll see near real-time latencies for such systems. But they are pretty compute intensive.
Nvidia launched a pen drive kind of GPU, which says that now no need of the cloud, right? From home you make your PC with the
Yeah, it's a box this tiny. So we call that DGX Spark. So this much, and it has some. It's not costly in traditional terms, but yeah, in India I think it will cost about 2 to 3 lakhs. Don't quote me on this, but it's coming soon. So, but it has some 200 odd tops of compute power, which is incredible. So that is coming soon. But yeah, if you have that, you can run it out of your workstations as well. It also has, we had a collaboration with another chip builder, MediaTek. They created the CPU and we created the GPU for that, and it has our latest Blackwell architecture GPU. So maybe in a couple of months' time, because July is the official release timeline, after that you can get it for yourself and have AI running on your system, on your desktops. So if you can go to the next slide. So the next one maybe, you just skip this. So coming to game development. So it is not right now that we are thinking about it, it's already been done. So I'm showing you a couple of videos. If I can play the video, if you can play the video, just check once. So basically, gaming was our DNA and is still our DNA. It's from where Nvidia started. So whatever advances that we have done in generative AI, it has been imbibed in our learnings. Maybe I can share this deck with everyone present over here, and you can just play these videos. So there are 3 games that I wanted to show. So this is the first game where this entire scene, again, it's been generated using generative AI. Not a single frame over here is traditional raster-based rendering. So this is generative AI-based rendering. On top of that, you have LLMs integrated into your non-playing characters as well. So this is our stack for this. So now all the different games that are being developed, they have LLMs inside all the non-playing characters. So it's not like linear storytelling anymore. So there are characters with you are interacting, and based on your inputs, based on your reaction, based on your power-ups, they decide what to do. So gaming is becoming more and more immersive and more realistic. So this was one of the games where we integrated this. This is out there. I think it came out 1 year ago. This using Nvidia AI. Is this? I'm not sure of the name. It was there in the video. I'm not recalling that name. I will give you the answer offline. There's a game, Zamora, in the next slide that I'll be showing. So can you just move on to the next slide, please? So here again, this game here, the boss, the character again had the AI agentic behavior imbibed in it. So the way you move, the way you attack it, it learns that, okay, these are your strengths, these are your weaknesses. So imagine your boss is also evolving. It's not a set of straight linear activities that is going to get you that easy win. So games are going to become more and more immersive. So this is an example where we were showing, this is the game called Mir 5, where this is already running. It already has LLMs running in the background. And that's how the intelligent decision making comes in. And if we go on to the next slide, please. Next. So now coming to DLSS. So DLSS is something that Nvidia figured out that if we want to make gaming more and more appealing, the way the requirement of traditional raster-based rendering was growing, you cannot keep up with the physics. So you had to take AI assistance. So for every frame that you generate the next 3 frames, 4 frames artificially. So what you're doing is you are giving your game a FPS boost. So the more amount of FPS that you have, your games will feel more smoother. So that is being done using DLSS. So DLSS right now is in its 4th gen. So in this GTC that we had like a couple of months back, DLSS 4 was announced. It started with single frame gen, that you have an original frame, you generate artificial frame using the device driver that are residing on your gaming GPU itself. Then you have another real frame. Now we have come so far. For every real frame, we can generate 3 artificial frames. And that's how, like a game that you could play at 20 FPS at 4K, now it's possible to play it at 75 FPS, 60 FPS in 4K. So that's how even deep learning and generative AI is helping us in gaming. So everything comes together, the LLMs, the ACE platform, the digital human, SDKs, DLSS, everything is coming together to help us shape this next generation of storytelling. And that is what I wanted to discuss with you guys today. And coming to the next few things, it's really a pity that I could not play that video for you.
So when you say it generates the AI generates the next 3, 4 frames. So the game which you are playing, it has got some environment. So hope that it takes that same environment to predict.
Exactly.
Right?
So it does optical flow calculation on the basis of how you were moving, what your next movement will be. There are Kalman filters. So there's a lot of techniques. It's not just generative AI. It's a combination of multiple things, but it's generative AI that is generating these frames for you.
But
So
DLSS is quite expensive for the hardware.
DLSS is not expensive anymore because right now your next generation Blackwell GPU, the RTX 5080s, 5090s, whatever is coming out, they have dedicated tensor cores or AI cores. Earlier it used to be expensive because you did not have dedicated cores. Now you have dedicated cores to just run the AI on.
So you guys added those from the 5000 series?
From the 5000 series, yes. It was already there in the 4000 series, but we boosted up the number of cores, number of streaming multiprocessors that we had. And like, I would love if you guys come to our Bharat Pavilion and I can show you the videos that were not running here. Maybe we can show all these videos there. Is it running now? Okay. In this video, basically what we show is that we show you this artificial boost in frames actually boost your FPS. So there's a FPS counter at the right side of the screen. If you observe that with DLSS off, it is at 1820, and just as you turn DLSS, it shoots up to 7080.
I do have a question.
Yeah.
I have been following and I see amazing stuff done with AI, but my question is how long you can make a scene consistent? Because you see very short scene, which is nice, but if you want to make a movie, and you need larger scene, longer time, how long can it stay consistent?
So,
Crashing, I mean.
yeah, hallucinating and creating something weird. So it's again like how we train our LLM. So text was pretty easy because text you start from 500 characters, then you scale it up to 1000 characters. And if you follow these recent announcements, Google would say they have come up with 1 million tokens that it can understand. Now it's the same problem with videos, but with videos it's a 2-dimensional, actually it's a 4-dimensional thing. You have your RGB and your frames, which is essentially sampling in time. So it's again an effort on the computing side. So if you have bigger and bigger infrastructure, you can train these models, and that's what all the companies are going towards. First, they have proven that this technology merits more investments, more focus. Now that has been established, people are establishing server farms where they are taking longer context videos, so that maybe they started with 10 seconds of individual clips on which it was trained. So you could generate maybe 5 or 6 seconds of video that was consistent. Now slowly and slowly these model context lengths are being increased so that you can generate longer and longer consistent video. So again, like the technology, it requires 3 things. You need, for any generative AI application, it's common. You can pick up any generative AI application. You always need 3 things. You need the compute, you need the data, and you need the right set of algorithms. So the data we do have. We have the data. Algorithms, we now know what are the recipes and how to scale these recipes. So we have scaling laws. The first of the scaling laws that started to come out from OpenAI, multiple companies worked and figured out that there are more scaling laws. So we know how these algorithms scales. What we are rushing as a company is to enable everyone on the compute front, because more and more compute needs to be provided, or else the cost of computing becomes exponential. So that's why like our company moved from a 2-year, 3-year cadence to a 1-year cadence, because that's the requirement of the industry right now. That if we do not increase compute, the amount of money that you have to spend to just move from generation 1 of a video gen model to generation 2, you are not going to be able to justify the economics for that. So as and when the compute becomes more and more powerful, it will lead to video generation model where you can have longer and longer consistent videos.
So I'd say you are doing historical document. You see the scene, you have to place characters there from different angles and even longer scenes. It's still not possible. No, it's challenging.
In gaming, it's fine.
Gaming, yeah, but in gaming you build the world before.
Yes. So you have a frame that you created, and from that you are creating 3 subsequent frames. So that's easy.
Or from a prompt. So the AI can create, and if it can create the 3D world and place the camera as traditional 3D, that is possible. But that is not what AI do, no?
So right now we have integration called OpenUSD and OpenUSD code. So companies, their advertisement companies like WPP, who recently made an announcement with us during GTC where they have incorporated generative AI, and they were doing the marketing campaign for some brands where via prompt they were able to put assets in different arrangement, and the entire marketing campaign was run by WPP based on prompting. So that's happening as well. But that's a different flow. Okay. That's a different flow than what we are showing over here. This is a different problem, and That is something that integrates with Omniverse. So Omniverse platform has been created for your collaborative and non-destructive workflow migrations, where you have your Blender Connect, your Maya Connect, and
Unreal Engine, for example.
yeah, Unreal Engine also gets integrated. So Omniverse has these merging pipelines, and also now, since we have added the generative AI pathway, you can just interact with prompts. So that's being done right now. Yeah.
You said okay. You said it works well with gaming, right? When you consider DLSS in gaming, especially when you use Unreal Engine or even Crytek Engine, as you generate and use more DLSS, it also takes up more resources, right? So in a way, instead of making people use your DLSS at a lower price point, you need more and more higher price point of hardware also for gaming at higher FPS and better quality immersive. So in what way is it efficient enough to generate DLSS or even fake frames in gaming when it takes more resources and also a lot larger time than rasterization?
Actually, rasterization takes longer time. What we are trying to do is the amount of compute that you require, let's say the same amount of FPS you want to render it traditionally using raster and your ray tracing. The amount of resource is going to be exponential. AI brings down that resource count. You are upgrading to a 5090 to get a AI enabled core, but actually in terms of commercials, if we just create bare hardware with which is just having ray tracing and raster cores, it is going to be it's going to be exponentially more expensive than the DLSS systems, because the amount of rasterization does not scale linearly, is what I'm just trying to portray. So that's the reason why we had to bring in DLSS, because if you wanted to increase FPS, you wanted more and more resolution to be supported, rasterization was not scaling. So that's why AI came to rescue, and it is helping us this way, so we can make the games feel much more smoother, much more realistic.
Are you guys also working on reducing the lag requirement compared to raster also?
Yes. Okay. So the input latency, we are also working on input latency. So it's a feature that is going to come out in a few months as a hot patch on top of your DLSS if you're already running a 5090 series. So you'll get that as well. Sure. So thanks guys, thanks for joining us.